so welcome back again to a new lecture, that is lecture number 16, and in this lecture we will discuss about another type of theorem, that is theorem number 8.6. Okay, so let us first understand the statement of theorem 8.6. The statement states that the diagonals of a parallelogram bisect each other. It means if there is a parallelogram like this, suppose this is a parallelogram, okay, now in this parallelogram, how many diagonals possible? Two diagonals possible, right? Diagonal AC and diagonal BD, and both the diagonal intersect each other at a common point. This point, let's say this is O, and this is known as point of intersection. Now according to the statement, these two diagonals bisect each other. That means the diagonal BD is bisect at the point O, and the diagonal AC also bisect at the point O. It means this is equal to this, that means this half is equal to this half, and this half is equal to this half. Already we know this property. Okay, previously we have discussed about this property, but this is a theorem, that is why we have to verify that each diagonal is bisected by another diagonal. So we have to prove OB is equal to OD and OA is equal to OC. Understood? We have to prove this, right? So let us write what is given here. So given. So what is given? ABCD is a what? ABCD is a parallelogram. ABCD is a parallelogram. Understood? ABCD is a parallelogram. Now, what do we have to prove? We have to prove that both the diagonals bisect each other. It means if there are two diagonals SC and BD, okay, so we have to prove two diagonals bisect each other. Okay, that means AO is equal to CO, AO is equal to CO, and BO is equal to DO. Okay, so now let us prove. Right. See, already it is given ABCD is a parallelogram. It is a parallelogram, it means the pair of opposite sides must be parallel and equal. That means AD and BC are parallel as well as they are equal. Similarly, AB and DC are parallel as well as they are equal, because as you know, in case of a parallelogram, the pair of opposite sides are parallel as well as they are equal. Okay, now we can write AD parallel to BC. So AD parallel to BC. Okay, if we consider AC as a transversal line and AC as transversal line, we have taken AD and BC as two parallel lines because it is given, and AC as a transversal line. Understood? Now, since AC is a transversal line, then this angle and this angle are known as alternate angles. This angle and this angle are known as alternate angles, and the alternate angles are equal. We know. So we can write that angle DAO, this angle, right? This angle DAO is equal to which angle? This angle BCO, because they are alternate interior angle. Okay. If you remind, then you can write the number of the theorem. Since I have forgotten the number of theorem, that is why I have written alternate interior angles. Similarly, if we consider AD and BC as two parallel lines and DB as a transversal line like this, this is AD and this is BC, two parallel lines, and DB as a transversal line, right? Since DB is a transversal line, then this angle and this angle, that means this angle and this angle, are known as alternate interior angles, and we know the alternate interior angles are equal. So similarly, we can write again and again AD parallel to BC with DB as transversal line. DB as transversal. Okay. So we can write that this angle is equal to this angle. ADO implies ADO angle is equal to this angle, CBO angle. CBO angle, because they are alternate interiors. Okay. So initially we have found DAO is equal to BCO. DAO, this angle is equal to this angle. And now we have found this angle is equal to this angle. Okay. So let's say this is our equation number 1 and this is the equation number 2. Okay. But our target what? Our target is to prove that both the diagonal bisect each other. That means this half is equal to this half and this half is equal to this half. In order to prove this, we have to consider two triangles. This triangle and this triangle. Which two triangle? Triangle ADO and triangle CBO. We have to compare between them. Okay. So between triangle ADO and triangle BCO or CBO. Okay. The first case is, since for the triangle ADO this angle is equal to for the triangle BCO this angle. Yes or no? Yes. Since we have proved it in equation 1. So simply you can write angle DAO. Okay, this angle is equal to BCO. Because we have proved it equation 1. Second statement. Since it is a parallelogram, then the pair of opposite sides are equal, right? That means AD and BC are two opposite sides and they are equal according to the property of parallelogram. Since AD is a side of the triangle ADO and BC is a side of the triangle CBO, so we can write AD is equal to BC. Okay, AD is equal to BC. Why? Because ABCD is a parallelogram. Understood? Now coming to the third condition. The third condition is that for the triangle ADO, this angle, okay, for the triangle CBO, this angle, these two angles are equal. ADO is equal to CBO, since we have proved it in equation 2. So simply you can write ADO is equal to CBO. It is due to we have proved, or it is given in equation 2. Understood? So here we have found three conditions. Let us verify to which congruency they follow. Right? So let us consider the triangle ADO. In triangle ADO we have taken DAO angle, DAO that means this angle. Then ADO angle, ADO that means this angle. Then AD side, that means this side. Now S, this side AD, S is the included side of the two angles. Understood? So by angle side angle congruency, this triangle and this triangle are congruent. So we can write by angle side angle congruency, triangle ADO is congruent to the triangle CBO. Now you understood? We have proved that this small two triangles ADO and CBO are congruent. Now see, if we consider ADO triangle, right? Now AO is a side of this triangle. Yes or no? Yes. So AO is a side of the triangle ADO. And for the triangle CBO, CO is a side. Yes or no? Yes. So CO is a side of the triangle CBO. Understood? But what we have proved? We have proved the triangle ADO and the triangle CBO are congruent. We have proved it. That's why their corresponding sides must be equal due to axiom 7.2. So simply you can write implies AO is equal to CO. So what we have found? We have found this half AO is equal to CO. It means what? It means the total diagonal AC is bisected at O. Yes or no? Because at this point of intersection, this half is equal to this half. Simply you can write that AC. It means AC is bisected at O. Understood? Similarly, since it is due to axiom 7.2, right? Similarly, if we consider the triangle ADO, then DO is a side of which triangle? Of triangle ADO. Similarly, if we consider CBO triangle, then BO is a side, this one, of the triangle CBO. But initially we have proved that this triangle and this triangle are congruent. That means if any two triangles are congruent, then their corresponding sides must be equal due to axiom number 7.2. So here also you can write BO is equal to DO because they are the corresponding sides. BO is equal to DO. Okay? So we have found that BO, this distance, is equal to DO, this distance. So this half is equal to this half. So you can write it means BD is bisected at the point of intersection or at O. BD bisected at O. Understood? So initially we have found that AO is equal to CO, and now we have found that BO is equal to DO. Okay, this half is equal to this half, and now this half is equal to this half. It means both the diagonal are being bisected at the point of intersection, or you can say both the diagonal bisect each other. Here, so finally we can write hence AC and BD are diagonals bisects each other. Okay, now it is proved. Here also we have to prove what? We have to prove AO is equal to CO and BO is equal to DO. We have proved, or you can prove two diagonals bisect each other. So we have proved that two diagonals AC and BD of a parallelogram bisect each other. Okay.